All right, so here is the notes for 2.8, which was being able to graph an absolute value function. So obviously this is graphing, so you might want to get a straight edge ready to make your graphs nice and neat. So first off, just building the graph. Absolute value graph can be thought of as a piecewise function. In my class, I related this back to back when we used to solve absolute value. So if you have absolute value of x, um, let's say, I don't know, x plus 5 equals 6. I taught my students to always think about absolute value being a distance. So this is the distance of x plus 5 is the 6, which means x plus 5 can actually mean it's a negative 6 or it's a positive 6. And then from that point, you would split it into two parts. You'd have x plus 5 equals a negative 6, or x plus 5 equals a positive 6. Positive 6. So that's going to be the general premise of what I'm going to do right now. The absolute value graph can be thought of as a piecewise function. Now, if you remember piecewise, it means that there is two pieces that make up the function. Using the same kind of concept that we just did in the top right-hand corner, if the absolute value of x is equal to y, that means that that x value inside of there can either be a negative y or it can be a positive y. And then setting up the equation, it would say y is equal to x or negative y is equal to x. Now, negative y is equal to x, you can actually rewrite that by using the multiplication property of equality and multiply both sides by a negative 1 will give us y equals negative x. The reason why I did that is because I'm about to graph this thing. On this first one, your slope, it is a 1 over 1. And then your y-intercept is a 0. So let's go ahead and graph that. 0 is right here. 1 over 1 is up 1 and then right 1. All right, and then we're going to draw our line. Make sure it goes through those 2 points. That's what that line would look like. Okay, and the other one, the one on the bottom, so I'll do this one right here. So your m here is actually negative 1 over 1. So it's the same slope, only opposite signs. And then b equals 0 still. So we're starting at 0. So if you notice, it crosses at 0 right there. And then now we're going to go up 1 and then left 1. Or you can go down 1, right 1. That's fine too. So you can go down 1, right 1, or up 1 and left 1. Oh, there's an interruption. Okay, so now that we have 2 points, we can make a line. So making this line, make it go through those 2 points. Or almost. Hold on. There you go. Okay, so that's actually what happens when you split it all apart. Now there's a problem here though. This is not a function. If you look at it, it fails the vertical line test. It fails it miserably. So we need to make it so that it actually makes sense. Now, looking at this right now, this actually, it's not the best representation of what this actually is, because if you plug in an x value of a 1, which is right here, if you actually plug that in right here, what's the absolute value of 1? The absolute value of 1 is a 1. So when you plug in a 1, you get out a 1. And that's what you get when you plug it into that equation. So 1, 1, that's your actual point. And this blue one down here, actually, it can't really be part of your graph because this is an absolute value. Another way you can think about this is if you take the absolute value of any number, you're going to get a positive number out. So all your y values should be positive, which means that these parts down here, your y values are all negative, so you don't actually count those pieces to be part of your graph. So what I'm going to do is, instead of squiggling it out like that, I'm just going to erase by shortening. So that would have been there. This one shouldn't have any negative values either, so that is right there. And that is your graph. That's how it kind of comes about being a piecewise function. The domain restriction would basically be your x, or your y values wouldn't be negatives. And that would be, on the first one, your x values, sorry, this one right here, you want to keep your x's that are greater than 0. This one right here, you're keeping your x values that are less than 0 or less than equal to. Okay. Parent graph. This is going to be basically, that's one way you could thought about it, like the way I just showed. Another way is just make an XY chart. Um, use the most basic one. So use 0 in the middle, go up 2, down 2, and plug them in, see what you get. So when you plug in a 2, absolute value of 2 is a 2, so that point's 2 comma 2. Plug in a 1, absolute value of 1 is a 1, 1 comma 1, 0 is a 0, 0 comma 0. Absolute value of negative 1 is actually a positive 1 again, and absolute value of negative 2 is a positive 2. So this is another way you guys could have built the graph. So 2, 2 is right here, 1, 1 is right here, 0, 0 is right here, 1, 1. And if you notice, that is actually looking a lot like that. So this is another way that you could have thought about it. Actually got a nice little one right here. Throw in there. Ha ha. There you go. Get in there. All right. There you go. Okay, so now that that's said and done, that's how the parent graph came about. It's called parent graph because it's the most basic graph. There's nothing around or fancy around it. There's no +5, no -7. It's just y equals absolute value of x. So most basic function. All right, graphing form. This is just what I call it. I have yet to see a book that they tend to call it different forms in different books. So I just call it graphing form. If you'll notice, we started with the parent form, which is y equals absolute value of x. Now we have new pieces, an a, an h, and a k. We call this, or I call this graphing form, because that a, h, and k actually gives us information about how the parent function moves around and is either stretched or reflected and things like that. So here's how this works. A is similar to a slope. Not exactly, but you're going to use it kind of like a rise over a run. H and K are going to give you a vertex. Now, one thing to focus on, though, is that this is a minus H. In math, that minus sign means opposite. So you're not going to just see x plus 5 and think your H is a plus 5. You actually got to take the opposite of it. So if x plus 5 was in there, your H would be a negative 5. So take the opposite sign of whatever's inside of the absolute values with the x. Those are also known as a shift. So H and K will be your shifting. Now, H, turns out, will shift your graph from the right to right and left. K will shift your graph up and down. Vertical shift is K, horizontal shift is H. So just to go over these real quick, this is one way you can think about it. So notice that +3 is on the outside, so that must be your K. It's a +3, so that's going to be up 3, because that's a vertical shift. 1, 2, 3, and there you go. So we just took our parent graph and moved it up 3. Now, if you saw this, -2, your K is a -2. So remember, the K value moves it up and down. We know it's a K value because it's outside of the absolute value bars. So this would shift it down 2. Okay? Now, starting with the parent graph in the middle, +3, notice it's inside. So that's an H. It's inside with the X, so it's an H value. Inside is opposite, so that's going to go not right 3, it's going to go left 3. 1, 2, 3. There you go. And -2, so obviously that's going to be the opposite way because it's a negative. Negative should be left, but inside opposite, so it's +2, so it goes this way. Okay, that's kind of that's one way you can think about this. There's different ways you can do this, but that's probably the best way to realize how it moves around. Couple steps of graphing here. First step, identify and plot the vertex. The vertex is actually h comma k. I don't know if I said that over here. Yeah, I did. Okay. Vertex is h comma k. So you're going to find your h and k. Then identify a. A is the number in front of the absolute value bars. You're going to use a like a slope to get half of the graph. You're going to get the other half by doing the opposite. Not the reciprocal, the opposite sign. Kind of like back here where I told you that we had one slope, but then we also had the opposite slope. So you got to use both the slope and the opposite of the slope, meaning the negative of it. Okay. And then, so let's go over this. So first off, vertex. This is my H, this is my K. All right, so vertex is H is -2 because it's opposite. K is a -3. So there's my vertex. My A value, there's no number here, so let's call it a 1. Here's how you plot this. First plot the point, -2, -3. So left 2, down 3, there's that first point. Use your A like a slope. So 1 over 1, you're going to go up 1 and right 1. So go up 1 and right 1. You can put another point if you want to. You don't have to, but it'll make your line straighter. Put your pencil on the vertex and then connect the lines going out one way. So remember, this should look like a V. That's half of your graph because this is your vertex. That's the middle. That's one half of it. Get the other half by doing the negative of the slope. So you're going to go -1 over 1. Now, instead of thinking you go down 1, right 1, go ahead and go up 1 and left 1. Go up 1, left 1, up 1, left 1. So you have the negative slope also going this way. Reason why I said you can go down 1, right 1. I'll put this in green. But the thing is with that is if you draw this way, this no longer passes a vertical line test. You won't have a function. So you can't do that because this is a function. So this should be your graph. Okay. Plus before how we said that there's domain restrictions on this thing. So let's try this one. So vertex is -1, +4. A is a 2 over 3. So we're going to start at -1, 1, 2, 3, 4. Then we're going to go right to, wait, is that right? Whoops. That's a -4. Haha. Silly Mr. Aguirre. -1, 1, 2, 3, 4. Down here. Okay. There you go. Ooh, that's a bell. Yeah, it's end of school year. So you're going to go up to, not school year, school day. That way. Okay. Then you're going to do the opposite also. So you're going to go -2/3. But remember, you're not going to go down 2, left, right 3. You're going to go up 2. So you're going to act like the negatives, I guess, on the bottom part if you want to think about it like that. Up to left 3, right here, and there you go. Okay, I'll do one more with a negative. Looking at this one, vertex. Now, this is K. There's nothing on the inside, so that's going to be a 0. Your H is a 0 because there's nothing on the inside with the X, so K is a 4. Your slope is going to be a -3 over 1. So 0, 4, start at 0, go up 4. -3 over 1 means down 1, 2, 3 over 1 this way. Now if you notice, when I connect my vertex to the point, it's going to be upside down. Alright, so now we're going to do the opposite slope. Opposite slope is not going to go down 3, right 1, it's going to go down 3 and left 1, which is right here. Now you connect it, and that's it. Okay. Now the opposite of this slope was +3 over 1. So instead of going up and to the right, we went down and to the left because that's still the same slope as that one. And that's it. So when A is negative, so it turns out when your A value is a negative, that it flips your graph over, it reflects it. So it turns upside down basically. And that's it. Okay. And that's how you graph absolute value functions on an XY axis. Okay, bye-bye.